Okay. Bring up the course material, the slide. All right. The topics that we are going to learn today is vulnerabilities. We are not yet going to today to strengthen any points if that becomes part of vulnerabilities. We just to see the vulnerabilities. In general, when you see vulnerabilities, we look at the infrastructure vulnerabilities. We look at network vulnerabilities, media vulnerabilities. We never consider software vulnerabilities so far. So in this course, so we'll look at that. The slide shows you some of the examples. Motivating example is this. We'll do also the hands-on labs. If someone says enter your name, then give your name and then age. We can say, if I say John, then in this input statement says, John, please enter your age. And then this age, enter your age. Right. Then if we subtract it by from 2023, then it gives us a year. So do you remember what happened in the year of your the year of your birth? The remember or remember not? And see here, the issue there is unsecure. This is not really the secure codings. Part of the reason is it doesn't care about the values that user may enter. User value needs to be sanitized because this is user interactions. You see lots of at each step there's a user interactions. In the user interactiveness, then you have to user enter something. Then you always need to sanitize the user's value because in part user may not understand your the prompt statements, or user may intend to give you some attackable strings. Unsecure codings needs to care not only user values but also external resources. If your code needs to receive some from external resources, it could be other like internet provider, or if there is an API server, then it may give you some trouble. I have another trouble here, web browser. For example, if your program expect user to submit image file only, and also image files, there may be many different extensions depending upon the image formats. It could be JPEG image or SVG image, or GIF images, many so many different ways that user may enter, user may want to upload. If there is a document, also many different ways. Therefore, if you want to receive some external resource remotely from arbitrary users, one of the relatively secure data format is PDF data formats. Not even documentation format, not even PPT formats, because documentation, PPT or Excel, many of those well-known file formats may cause lots of cybersecurity issues because it has a macro maybe included, but PDF does not have macros. Although PDF may have something in addition to the text that we see, but PDF almost like a plain text files. Therefore, many cases they prefer to receive PDF rather than doc file or PPT files. That may be thing. Communication, that is also a big issue. Through the communication, the attackers may come in our system. The way they want to come in is they want to invoke the program that we provide. Okay, so those are all vulnerabilities. The goal of the coding is to make software packages to function correctly, first of all, and then to include additional functionalities without having to make a major change in the code. If we can include more. That is the improvement of functionalities. And then we have to consider error handlings. In coding, we usually call it exception handlings. Exception handling is one of the major topics that we discuss in this class, in this semester, in this class. Okay. So improving functionalities, there's an improve of time complexity. What that means is that your code needs to be complete within a reasonable time. And also, by including additional functionalities, then we can also improve our functionalities. Exception handling, error handlings, that may add the quality functionalities of our software. Possible vulnerabilities occur when data is given by user or external sources, as I explained it. Data is fed into a function or a module. Part of this, if you understand well, then you may be able to recall one of the homework assignments that I asked recently. As you review Python skill sets, part of that is the way that you can invoke function, because function is externally defined and you do not know whether that function is securely implemented, right? To avoid that, then we can use some other type of the data that we want to send. We're going to revisit that today. Okay, but I already asked you to consider that as you review Python skills, which was the previous homework assignments. And then vulnerabilities may occur when data is returned from a function. So when the function returns the resulting data, the execution result, then you have to also sanitize that returned data. And also when data is manipulated between lines in a code, of course, then that is vulnerable. And also system call is post. When a software try to execute one of the system calls, then system call usually touch something sensitive with the super privileges by itself, therefore vulnerable. When sub process is requested, then that is also vulnerable. When an operating system command or query expression is posted, then vulnerability comes with it. So for example, given a list of numbers, then we can sort it, right? Numbers in this first example, integer, fine. What about not only integer but floating points? This function sort also work, right? What if we have a nested list? Not only one flat list of numbers, but nested list of numbers. So a list contains number list. Still, we need to do that, right? This will be practiced. Given a dictionary like this, then extract a list of values from a new dictionaries. So how can you list of values? These are the list of values. And sort the values, right? The way that you can extract the values that is associated with each key, then you better extract this and construct a nested list that we looked at in the previous example, right? If we can extract values and construct this kind of nested list, then that makes sense, because this set is the value for one key, another set that's for another key, and this is for another keys. That we preserve like this, if that is a dictionaries, then these three listed integer is for the key A. These two are key 2, and the other and another key and another key. So how can you sort them? Part of the way that we can sort appeared here. So what we are trying to do here, our goal is this coding is to improve the functionality first of all. After that, we have to avoid any exceptions if there is exceptions. Okay, so far, okay, up to this, we want to improve the functionalities like this. This is functionalities. But on the way, there may be some attack. Then we have to consider the exception, and that exceptions needs to be handled properly. If you see here the code, this is a given code, I believe. And we can add exceptions. Exception is, if you see here, this is a function, right? Given data, and then for each key, we can get the value. This is the values. And then if there is a replace, then we need to get the given a list of values, we can make it a tuple of values. So tuples can be in tuples is the form that we make data for the key in a dictionary. Along that way, then we see here exception handlings. We do not do exception handling yet, so we don't go deeper inside. We want to see the concept, why we need to do handling exceptions. While we are improving the functionalities, then what that means is that we include more cases, wide spectrum of cases that we want to handle. Then there may be some exceptions comes with it. Then we have to consider the exception handling as well. That's what I wanted to be motivated. Okay, so without further doing this, what I want you to do, I have let's see. Wait a minute. This is so bright. My background is so bright. Okay. I wanted to guys to have collab. So I am trying to give you the collab files. should be like this. And I'm going to post that on your Blackboard. So I want you to download it. Can you see the collab files? If you see the collab files, then first download it on your local file systems, like your laptop, and then on your web browser, you can type collab.research.google.com and then upload that file to collab facilities so that you may have this. So please do that now.
Is it fine if mine doesn't open up in Google Colab? Mine opens up in Visual Studio.
I'm not sure. Do you think Visual Studio can
The
render
format looks exactly the
IPINV?
same.
Or oh yeah, if you see your Visual Studio environment shows very similar to the one that you can see on your Zoom screen, then that'll be fine.
Okay.
I don't see why not. Interesting. I didn't know that Visual Studio has the same that we see. I'm wondering, everyone, anybody has any issue?
Oh, I see it. I'm doing it right now.
Okay. Anybody needs more time?
I'm working on it. This is we're going to have to submit this, right? Obviously after we finish, right? Or is this the homework?
No, you are, no, you are not. No, probably on your Blackboard,
Okay.
I posted it.
Okay, I got it. Don't worry. I got it. Thank you.
Okay. I think he'll be okay. All right. So everybody's have the same.
I got it. Don't worry. Sorry, I just got a little confused. Don't worry.
All right. Sorry for that. Okay. Yeah. Here, lab 4, software vulnerabilities. I'm trying to make this the lab platforms so that we can see the all together the same coding list. Although I put there also some of the homework assignments. But today, because you guys did to review your Python skills last week, I know you already submitted. I looked at a few of your samples. They are good. So no homeworks from this notebook. But anyway, we'll look at this. The goal of this software is to correct functionalities and secure functionalities. So we look at 4 parts: software incompleteness, software exceptions, and then file extension and file readings. Those are all related with the vulnerabilities. First, software incompleteness. This is the same as that we looked at on the slide. So given data sets, we can make a sort, right? So if you click on this triangle, then you can see the result of that sortings, right? If you want to see the result, then you can simply either simply type that variables, then you can see it. Or if you want to, if you do this, then if you have a long list of the code segment, only the last line where there is a something is self-evaluated, then it can display it like this. If you want to see many of those, then you have to say explicitly print. I think you guys all know, right? Print statements. Then you can see at any points of your code segments, it'll print out so that you can see it. So in this way, you can sort this, right? Question is, how do you see the result? Yeah, we can do that. By assigning statements number 5 of the code here to a variable, print the variables. So if I say, how can you see it? You may see like this, but somebody may think, I want to assign it. This sort will be assigned to other new variable. So the result of sorting will be assigned to new variable, so that I want to print it. Usually it works, but not all the times. Particularly in this case, what do you have? None. Then another instance may say, another developer may say, a statement of sorting a list, then keep the list of variables. Oh yeah, this is something that we do, right? So in this case, you can see it. What if the sorted list is assigned to itself? So if you want to do this itself, what happens? Still none. I want to see all those 3 cases. Here, simply assign it new variables, then that is null. If you don't do anything but simply sort, then you can get the result. If you sort and assign to new ones, no, not new ones, itself, by itself, to itself, still null. So what happens here is that soon as you assign this to new variable, this new variable is a brand new variables. These are clean variables. Okay, this guy does not return anything. There's no, if you evaluate this, there is no returns. Therefore, it'll be null. Therefore, same thing here, null. If you execute it, then it execute and change it by itself, and that is done deal. Okay. How do you know then these things? You have to. It doesn't say this, right? For example, if you do in the list, if you do append or extend or pop or remove, then it has something, right? But you can assign that to some other new variables. Fine. But this particular method, sort, don't try to assign. Okay? If you assign it to another variable or assign it to yourself all the time, as far as there is an assignment, that'll become null. So when you sort it, that's it. Don't do any additional. So sorts works like this. What if we have nested ones? What happens? So if you click it, what does this guy? This guy sort 7 first, 9 and 12. Only look at the first element of that list like this. It doesn't see any additional element in the nested list. How can you improve it? There may be many ways that you can improve it, right? You can sort the nested list by number of elements, or you can sort the nested list looking at the maximum number there, or minimum number there, or average, whatever. So each one that you may have different ways that you could do, right? So you need to make the functions to do something. So for each data, what you want to do, when you do data, then you don't need to do this, right? This is order. Rather than sorting, you have the order. We rename it. Or if you want to rename it, you can rename it also. But let's keep it differently. So let's put it order rather than sort. So by taking the data, so data could be, I think this is our data, right? So we can do say this is our data. Let's call it data set 3. So we can print that data sets first. Data set. Okay. What this guy says. Yeah. So depending upon our implementation, we can order this. If we want to say for each in data, so we take each one of these, right? And then for example, if we want to make a sum, then you can do new list. We want to make a new list. And then finally, we can return new list. So we need to build the list from scratch by reading each nested list. How can you do append? Are you going to make sum? This is each element. So you should not do this. If you want to make summation, then you need to make, rather than using sum, total equals to 0, and then you need to do total, you need to add each, then total can be accumulated to total. When it comes to data is there. Each is this nested. Okay. I thought it is. So we don't need to do this. We simply do here sum and each. Then it'll come to each. Because there is a sum is a function available. See here, if we see function takes iterables, which is a list. List is iterable. That'll be fine. It returns the sum of the start value, 0, plus uniterable of numbers. So this gives us good summations. For each nested list, that is each here. Each here, this each is not each element. This is each list. So you can say each list, then here each list. Because this is iterable, you can make a sum and append that to new list. That comes here. Okay. This is given. And then you can invoke these order functions and print that. Let's see what happens. Order set 3 is not defined. No, we have to do this data sets, not order set. Data sets. So this is given. We want to make a totals. Let's say if we have this is order, and then we have to do here sort. This is order. So what we want to do here, order let's make here sort. This returns null. Order. Okay, let's do step by step. So this is order the list. That is this. Right? So if we do order the list, then we'll get that. And this ordered list should be sort. And if we want to print ordered list, then we have that ordered list. This is ordered. So summation, all of this can be summed. So for example, if we put this 100 and order it, then 22, 29, 120. If we want to put here 800, then it'll be do 22, 120, 821. They sort that order from lower to higher. That is this. Okay, this is somehow the improvement. While we want to include more and more functionalities, as I said, then there may come exceptions as well. So how can we handle that exceptions? We can start with the small exceptions. If we execute this, 23 divided by 0, then there is an exceptions. There is an exception called division, zero division error exceptions that may occur, right? So we have to handle that. Like here 23 and we want to ask user to enter. If we do this, see what happens. Then here that is an error, right? There is a nominator, denominator. I think this is denominator is that. There's an indentation error, first of all. Then this guy says, enter the number. 23 divided by something. That's what we want to do, right? Nominator. Nominator is 23. Denominator is given right now, right? So if we do nominator is 23, denominator, if we say 0, then there is an error, right? Of course. So if we put 0, then there is an error, which is the same error that we looked at above. Therefore, we have to exception handlings, okay? That I made the exception handlings. If I copy that here, you don't have to worry about how you can make that exception handlings at these points, but simply I would say similar code. This is the same code as that. Only difference here, I put try. So what happens here is push that back, and here you can say try, and then here you can put except, and then exceptions. Exception as E. Therefore, that E is used here. Don't worry about this, but at point here is that if you have handles this exception case is comes when user enters 0, then exception is not defined. Oh, this is not. Error, XCP, yeah, typo. Then if we type 0, then remember that previously we have lots of the errors, right? If we don't do this try, then it gives me error because we have 0. But rather than that, it asks me, because we have a while loop, ask me to enter more. So for example, 2, then it gives me division is succeeded. Okay, that is what exception handles. So no worries now. So exceptions will be discussed from next week. Basically, exceptions, there are 2 types of exceptions available. Like this is an exception that already defined. But there may be user-defined exceptions needed as well. So we're going to look at built-in exception first, and then we'll look at user-defined exceptions followed. What that means here, when you enter 0 like this, then it gives me, this guy already know, hey, there is this kind of exceptions takes place on your code. So this guy picked that exception, right? The Python itself already identified what exceptions, what types of exceptions takes place on that code, and let us know what it is. That's what this case did. But there may be many other cases, a lot more and more cases that not defined by Python itself, but we have to take care of by ourselves. That's what we say user-defined exceptions. That will be done later. So this is software quality itself. But next small modules that you guys already did on your homework, there may be another exceptions. This is not really exception, but the safety issues, insecurity issues. Function is defined, or software packages is defined, and you want to use it by sending these numbers to deposit it. Okay, if you do it by itself, it works well. Okay, so 203.95 deposited. So looks like it is deposited. If you add this all, it may not be the same as this. I think the way that you can see, if we print some checklist, I want to do that first. So if you sum the check numbers in this checklist, then it'll be $270.59. But because of this, the functions, some of the packages, some of the fake bank, this guy want to change the second checks, no, I think third checks to 33.35. Whatever the third check comes, it'll come to 33.35. right? So that much reduced. So $270.57 deposited by calling this function, but function itself has some fraud. So it is reduced. Is there any way that we cannot solve this, right? This is a black box. We do not know how the system implemented and also operated in a bank. We simply see the deposit. The way that we can deposit, since this is the deposit, then we can do in another way. I want to say this is a check tuple. And rather than deposit checklist, I want to deposit check tuple. Okay. Then what happens? When I do, well, I have to make this tuple rather than list. Make tuple. Okay. So if it is in the list successfully deposited, but there is a fraud. But once you make this a tuple, your bank cannot deceit you because there is an error. It says tuple object does not support item assignment. Inside the tuple, any element in the tuple cannot be modified, cannot be manipulated. If you want to make this properly, then if this malicious code segment is removed, then both should work fine. Originally, that is a 270.59. Yeah, both are saved in this way, right? But once you have this, then this first case works like this, but second case, in the tuple case, error took place. Yeah, this is what I asked in the previous homework assignments. File extension. Each file has its own extensions, right? If there is a PDF, then PDF file extensions, and therefore that extension is an indicator to your operating systems to find proper application to run. If there is a PDF, then PDF reader needs to be open, and therefore your PDF files can be rendered. If there is a .doc file, then Microsoft Word documents is executed, and therefore that document can be rendered. Vulnerabilities in the extensions. Although that is a doc file, you can simply change it to something else. Therefore, your operating systems may be confused, or you can disguise your malicious documents to be something trusted. Then we'll look at how that extension code can be properly encoded. If there is a doc file, then properly it should be, extension should be .doc or doc files or PDF or JPEG properly. So you need to make sure not only the extensions, but that extension needs to be matched with something in your file. So you have to open up files not by using your application program, but you need to look at the code itself. In your code, each every file, then there is some of the metadata available that can identify the type of or format of the file itself. Okay, so it is so file type is there. So we need to find out. We need to first convert your file to. You have to read your file in hex code. So this code simply practice. If you have a hello, this is a John Yoon. Then how can you convert this hello? This is a John Yoon text to hexacode. This is the code for that, right? That is this. So type of code is a string. Hexacode is a string. Similarly, binary code can be generated. Same thing, this is a text, but this text can be written in hexacode. The very same thing can be written in binary code. This is simply a code. Given this simple string, then we can convert that to the code. If it is a file, then we can also change it by read the file and then we call the function hex. Then we will have this. File needs to be, when you read the file, then you have to do here read and B for binary. If you do not have this B, see what happens. If we do not have that, then you cannot do this hex. So you need to do it the binaries so that you can see the binaries. File can be opened from your Google Colab. This file is not just typed, but should be available on your Google space, Google Colab space. If you open the last icon here, it is called files. Open it. Then there is a sample data. This is the data that I looked at. So if I'm going to read something else. JSON files. Or CSV files. Anyway, this is all text files, right? So if you click this, and then there is a copy path. So you can bring that path and paste there. So this is content. This is a content entire. There is a sample data. This is a folder, sample data. Inside the sample data, we have California_housing_test.csv. There is this test here, right? So if you click this, then we can see hexacode of it. Similarly, if you have any image files, let's see if I have any image files somewhere. This is, I think this is old Mercy College logo. Double click it. Yeah, this is Mercy College logo. I want to bring this JPEG files. To do that, there is a small icon there. So upload to this session storage. So click on this and go to Mercy Slack. I think this is the JPEG files. Bring it up. Okay, so that comes up here, right? So if you click this and copy path, and then bring that path here, then there's the JPEG files. I'm not sure this is something. I want to rename this because there is a white space. I want to remove all the white space, or maybe underscore. This is not the right way. If there is a white spaces, so let's make this. I want to re-copy the path. Okay, then all underlined properly. When I click this, then I have this, right? So somewhere here, the first few characters are the indicator saying that, oh, this is a JPEG files. Okay. That is so-called header files. So if you see the header files, JPEG header files or hex, so-called signature formats. It says 55 dBF something. So 55 D8FF is a little bit different versions of hexacode, right? So FFD9 and so on and so forth. So somehow this is a hexacode, right? So looking at that hexacode, then we don't look at that. We do not today dive into all details of those. That comes later. But vulnerabilities takes place when there is no proper extension used. File reading vulnerabilities, file header, file extension errors. We looked at a little bit of those, right? Already. Yeah, a little bit of those. This is something different. Here, this is a session file storage. You can also connect to your Google, what is it called? Google Drive, right? So if you have Google Drive, lots of the files available on your Google Drive. You can link your Google Drive here. Once someone is able to read your code, when your code contains Google Drive, then your Google Drive is vulnerable. Definitely. Okay? So while you are using this Colab, please make sure that your Google Drive is not linked here. together with a specific notebook, particularly when this notebook is released to someone else, then someone else can see not only your code, but also entire your Google Drive. If you save anything sensitive on your Google Drive, then your Google Drive is in jeopardy. That is definitely vulnerable. Okay, so we'll. So I'm not going to do that here. That is something like here. My Drive. It'll be my Drive. Because when you do Google Drive, then it is called my Drive. That may be linked to this. Anyway, so a little bit of the patterns that we look at, the vulnerabilities. So we'll look at from next week how we can prevent software vulnerabilities next few weeks. After that, we'll look at how we can make our software intelligent. So a little bit of machine learning techniques introduced, because our students, although take some artificial intelligence course, but didn't do much about machine learning. Right now, machine learning is the popular topic. So for the cases of cyber security, so we'll look at some machine learning techniques. And then finally, steganographies. That is the technique how we can hide some of the messages within the images, so that by sharing images, the messages can be exchanged, but no one else can see the messages because the message is hidden. Almost impossible to extract that messages. You may be able to see why it is almost impossible. Okay, I think this is it for today. As I said, there is no homework assignments for today. I'm not going to ask you to do anything vulnerable. I do not ask you to make something vulnerable. But I want you to understand the vulnerabilities. That's all the points that I want to make today. Any questions before we dismiss?
So you want us to understand the material, is what I'm understanding from
Yeah,
everything
yeah.
that you-
Yeah, practice the hands-on that we
Okay.
just did. Yeah, that much that we need to know today.
Okay.
Any other?
Thank you, Professor.
Okay. Have a good evening, and I'll see you next week.
Thank you. You too.
Okay.
See you, Professor.
Take care.